Hi there, Miss Barber here. The title of this lesson is Analyzing Arguments. The learning objectives for this lesson are: 1. Determine whether an argument is inductive or deductive. 2. Analyze inductive arguments. 3. Analyze deductive arguments with and without conditional propositions. 4. Determine the validity of arguments involving chains of conditionals. And finally, 5. Apply analysis of arguments to mathematical rules and conditional statements. We now consider those two types of arguments. First, the inductive. In inductive arguments, we go from specific premises to general conclusions. Let's consider this example. A premise: bluebirds fly. Premise: hummingbirds fly. Premise: cardinals fly. Conclusion: all birds fly. While it is true that all three of the premises are true, is it accurate to conclude that all birds fly? The second type of argument is the deductive argument. In a deductive argument, we go from the general premises to a specific conclusion. For example, consider the premise: all doctors are intelligent. And consider the premise: Dr. Jones is a doctor. Then, by the deductive argument, we conclude Dr. Jones is intelligent. Evaluating inductive arguments. An inductive argument does not prove its conclusion is true, so it is evaluated based on its strength. An argument is strong if a compelling case is made for its conclusion. An argument is weak if the conclusion is not well supported by its premises. Example: hit movie. A movie director tells her producer, who pays for the movie, not to worry, her film will be a hit. As evidence, she cites the following facts. She's hired big stars for the lead roles. She has a great advertising campaign planned, and it's a sequel to her last hit movie. Explain why this argument is inductive and evaluate its strength. Analysis. Because the conclusion is more general than the premises, the argument is inductive. Each of the three pieces of evidence is a special characteristic of her movie, and the director uses these facts to support the conclusion that her movie will be a hit. This argument is relatively weak because even the best planned movies can flop. Evaluating deductive arguments. Apply two criteria to evaluate a deductive argument. The criteria are validity and soundness. The argument is valid if its conclusion follows necessarily from its premises, regardless of the truth of the premises or conclusion. The argument is sound if it is valid and its premises are all true. There are some key distinctions between inductive and deductive arguments, provided for you as a table consisting of 2 columns and 4 rows. The first column is titled inductive. The second column is titled deductive. Under the inductive banner, a conclusion is formed by generalizing from a set of more specific premises, whereas with a deductive, a specific conclusion is deduced from a set of more general or equally general premises. Next block under inductive. An inductive argument can be analyzed only in terms of its strength. Evaluating strength involves personal judgment about how well the premises support the conclusion. Let's contrast that with a deductive argument can be analyzed in terms of its validity and soundness. It is valid if its conclusion follows necessarily from its premises. It is sound if it is valid and its premises are true. And finally, the last block. An inductive argument cannot prove its conclusion true. At best, a strong inductive argument shows that its conclusion probably is true. Now contrast that to deductive. Validity concerns only logical structure. A deductive argument can be valid even when its conclusion is blatantly false. There are several acceptable ways to test the validity of an argument. A Venn diagram is one of them. So let's look at a Venn diagram test of validity. To test the validity of a deductive argument with a Venn diagram, 1. Draw a Venn diagram that represents all the information contained in the premises. 2. Determine whether the Venn diagram confirms the conclusion. If it does, then the argument is valid. Otherwise, the argument is not valid. Example of an invalid argument. Evaluate the validity and soundness of the following argument. All fish live in the water. Whales are not fish. Therefore, whales do not live in water. Let's make a Venn diagram, and we'll start with an outside rectangular box. Within that outside rectangular box, we put in a circle, and we'll label that things that live in the water. And within that circle, we will make a subset that is completely contained, which is the fish. Let's observe that where we draw the magenta X, the premises are whales are not fish tells us to put an X for whales outside the fish circle, but it does not tell us whether X should be inside or outside the things that live in the water circle. So we place it on the border of this circle. The conclusion whales do not live in water would require an X outside of the things that live in the water circle, but the X from the premises is on the border of the circle, which means the premises do not automatically support this conclusion. Basic forms of conditional deductive arguments. We have 4 basic conditional arguments. Affirming the hypothesis is our implication. That is, if P then Q, P is true, then Q. This is a valid argument. This is our conditional implication. Affirming the conclusion or consequent says if P then Q, Q is true, then P is true. This is an invalid argument, and this is also the converse. We're saying P implies Q. The converse is Q implies P. It is not a valid argument. Denying the hypothesis. If P then Q, P is not true, then Q is not true. Symbolically, we would have P implies Q, not P, therefore not Q. It is an invalid argument, and this is the inverse of the implication. And finally, denying the conclusion. If P then Q, Q is not true, P is not true. That is, we have P implies Q, and not Q implies not P. Let's observe this is a valid argument, and this is the contrapositive. Example, affirming the hypothesis. Consider the following argument. Premise. If a person lives in Galveston, then the person likes the ocean. Premise. Dan lives in Galveston. Conclusion. Dan likes beaches. Analysis. Step 1. We first represent the information contained in the premises in a Venn diagram as follows. 1. The first premise is if P then Q, in which P is for the statement a person who lives in Galveston, and Q is for the statement a person who likes the beach. And then represent the second premises by placing an X inside the P circle. Let's observe. We have a Venn diagram that's a rectangular box with a circle enclosed in it marked with a Q, and within that Q is another circle completely marked in there who is labeled P. Notice that X is in the P. Now to step 2. Note that the conclusion Dan likes beaches implies that the X for Dan should be inside the Q circle. The X is within the Q, therefore the argument is valid.